So the turning point of a parabola and its general shape are relatively easy to determine if the quadratic function is written in its shifted or vertex form. So review this in the first exercise. So given this function, do the following. So the coordinates of the turning point, I need to remember what we learned last class, or last section. So y equals x minus h squared plus k, where the h is your x in the turning point and the k is your y. So for this one, the x is going to be 3 and the y is going to be 2. And then we're going to determine the range by drawing a rough sketch. So if I were to have a y-axis and an x-axis, that turning point would be at 3, 2, and since it is a positive x squared, then it's going to go up. It's going to be a happy graph. It'll be a smiley face. So the question then is how we take a quadratic form of y equals ax squared plus bx plus c and put it into its shifted form. This procedure is known as completing the square, but it needs some additional review. So remember, when we have x plus 5 squared, that's the same thing as x plus 5 times x plus 5. So x times x is x squared, x times 5 is 5x, 5 times x is 5x, and 5 times 5 is 25. We need to combine these so it becomes 10x in the middle. The other thing you can look at is, that you square the first one, square the second one, and then you multiply these together to get negative 1x times by 2, so negative 2x. Let's try that one again. Square the first term, which is x squared, square the second term, which is 16, multiply these together, which is 4x times 2 is 8x. So given each trinomial in the form x squared plus bx plus c, what is true about the relationship value between b and the value of c? Well, what's true about them is that we can take b divided by 2 squared and it will equal c. So let's look at A. For letter A, the b was 10. We could divide it by 2 squared. 10 divided by 2 is 5. 5 squared is 25. Yeah, that gave us C. Looking at B. Our B in that one was negative 2. We divide that by 2 and square it. Well, negative 2 divided by 2 is negative 1. Negative 1 squared is 1. But yeah, that was our C. And our last one, our B was 8. So 8 divided by 2 is 4. 4 squared is 16, which does give us our C. So each of the following trinomials is a perfect square. Write it in factored or perfect square form. So we can do what we just said, where we can go backwards. So we take our B, which is 20, divided by 2, and square it. Well, 20 divided by 2 is 10. 10 squared is 100. So that means our first term is x. Our second term is positive 10. Look at the next one. Negative 6 squared, or divided by 2 squared. Negative 6 divided by 2 is negative 3. Squared is 9. So x and negative 3 squared. And our last one, 2 divided by 2 squared is 1 squared, which equals 1. So we have x and positive 1. We're finally ready to learn the method of completing the square. This method has many uses, but the one we will work with today is to manipulate equations of quadratics from their standard form to their vertex form. So let's look at this quadratic. Consider only the binomial of x squared minus 4x. What would you need to add onto it to create a perfect square trinomial? Well, if I wanted it to be a perfect square trinomial, I would need to find what c was. So we take the b, divide it by 2, and we get negative 2 squared, which would mean that my c would need to be 4. So we would need to add a 4 to make it a perfect square trinomial. In order to add 0 to the binomial, what should we subtract given a? Well, if I have x squared, minus 4x, because that's what we were originally given, and we had plus 4, let's say that that's what we were adding up above. To make this into 0, I would need to subtract 4. I'm going to change that color to show that it's what we're changing. We're going to subtract 4 to make that 0. So use the method of completing the square now to rewrite the trinomial in an equivalent shifted form. So let's say that we have our completed square, which is x squared minus 4x plus 4. That's one we created, right? That's the perfect square. Then we said we needed to subtract 4. And please remember that we have our original minus 1 up above. So here's what we can do. We know that this becomes x minus 2 squared because of the minus 2 up here. And then we can combine these two to make this minus 5. So now we have this in the vertex form, or the shifted form. So the actual vertex is going to be 2, negative 5. And it's true that the vertex is at 2, negative 5. I know this is a lot of work. Hopefully with more practice, it'll become a little bit more fluid for you. So this procedure is what is known as an algorithm. In other words, we follow a recipe. So the first thing we're going to need to do is we're going to need to take b, which in letter A is 6. So 6 divided by 2 squared, which becomes 3 squared, which becomes 9. So now we have x plus 3 squared. Where that came from is I just created a perfect square and then skipped a step to make what the binomial becomes. So by doing that, and understanding that in order to make that 9, I need to subtract 9, because I always subtract whatever this is, and then we add on what was already here, which is negative 2. So it becomes x plus 3 squared minus 11. So our turning point, or our vertex, is going to be negative 3, negative 11. It is negative 3 because that means that double negative makes that a negative, or a positive. Because remember that the vertex form is y equals x minus h squared plus k. So since this is a plus, that means that our h has to be negative. Next one. Negative 2 divided by 2 squared becomes negative 1 squared, which is 1. So our perfect square binomial is going to be x minus 1 squared because of this negative 1. Since we need to subtract our c, we subtract 1, and since we can't forget what we started with, we have a plus 11, so it becomes x minus 1 squared plus 10. So our vertex is at 1, 10. Next one. negative 10 divided by 2 squared becomes negative 5 squared, which becomes 25. So our perfect square binomial becomes x minus 5 squared. Because we need to subtract what the c was, we subtract 25. And because we have our original, we add 27. So it becomes x minus 5 squared plus 2. So our turning point is at 5, 2. Our next one is a little bit confusing because we don't have a c to start with. So you need to remember that there's a plus 0 to start with. So still same thing, 8 divided by 2 squared. So it becomes 4 squared, which becomes 16. So our perfect square binomial is x plus 4 squared. And then we need to subtract our c. And then we have our 0 we started with. So it still is just x plus 4 squared minus 16. Please remember that because this becomes a positive 4, that means that our x is going to be negative 4 and our y is negative 16. 5 over 2 squared becomes 5 over 2, right? Which is the same thing as 25 over 4. So our perfect square binomial is x plus 5 halves squared. We need to subtract our c, so minus 25 over 4, but we have our plus 4 we started with. Fractions. So we still have our x plus 5 over 2 squared. I need to make this 4 into fourths so that I have a fraction I'm dealing with. I have negative 25 over 4 plus 16 over 4, which becomes negative 9 over 4. So our turning point is negative 5 over 2, negative 9 over 4. Fractions. Last one. We're going to do some more fractions. So we have negative 9 over 2 squared becomes negative 9 over 2 squared, which becomes positive 81 over 4. So perfect square binomial is x minus 9 over 2 squared. We have to subtract our c, which is 81 over 4, and subtract our 2 that we started with. However, the 2 needs to become a fraction we can deal with, which is going to be 8 over 4, so we have the common denominator. So it becomes 9 over 2, and negative 81 minus 8 becomes negative 89 over 4.